Welcome to the EC Council University Cyber Talk on building a lab to analyze Windows malware. I'm Brad Duncan. I'm currently a Threat Intelligence Analyst at Palo Alto Networks Unit 42 Threat Intelligence Team. I'm also the creator and maintainer of MalwareTrafficAnalysis.net, a blog where I share packet captures of malicious traffic. My goal, as you can see right there, is to share pcaps and encourage traffic analysis, which is not a field within information security that's emphasized as much as I think it should be. My career in information security began with investigating suspicious network activity, where I soon realized that I like analyzing network traffic. That led me to building a home lab, a process that included many mistakes and constant revisions over the years as time has passed. Today's Cyber Talk covers some of the important issues I've learned about building a lab environment to analyze Windows-based malware. In today's Cyber Talk, I'll start with an introduction to building a lab environment, and then we'll discuss virtual environments. After talking about virtual environments, we'll cover physical lab environments, and then I will start talking about network traffic from a lab environment, to record the network traffic from a lab environment. And finally, we'll discuss getting malware samples to test in a lab. Now, a good lab environment is unique to the person building it, so the details should not be public knowledge, especially since malware development is a cat and mouse game where developers are constantly updating malware to evade detection, while antivirus vendors and anyone else on the defending side are updating their detection. The defending side includes lab environments that test malware samples, which is something malware developers also take into account when they're trying to evade detection. And that includes labs like we're talking about today. A sandbox can analyze malware, but it usually has a time limit, or the malware might crash and it might not run as intended. By using your own lab, you can customize the environment to your liking, and you can run the malware for as long as you like. For example, I run certain types of malware for 2 hours, 3 hours, even overnight sometimes, to see if anything interesting happens. For something like an emotet infection, you may have to wait 2 or 3 hours before seeing follow-up malware activity, which is common with emotet. Dynamic analysis is running malware on a Windows host. This is the type of lab that I use, and that's the type of lab that we'll discuss today. A key feature of dynamic analysis is that we can monitor infection traffic. You can record the traffic and you can save it as a packet capture, which we will discuss later. Now, your goals will determine how much time and effort you put into building a lab. For example, if you want to check an occasional malware sample, you might only need just one Windows host in your lab environment, and that might not be so expensive. But if you want to simulate a work or enterprise environment with Active Directory and a domain controller, then you're talking about more resources, more effort to set everything up, and more money to purchase the applicable software license and computer equipment or resources that are required. Now, a significant amount of this cost will be licenses for Microsoft Windows. If you plan to analyze Excel spreadsheets or Word documents or anything else on the Microsoft Office side, you'll need a licensed copy of Microsoft Office. Now, acquiring Windows and Microsoft Office should be done legally, which means that you should pay for the software licenses in most cases, and this can be a significant cost. Fortunately, online retailers frequently offer discounts for Windows and Microsoft Office. And after you have everything set up, you can snapshot your virtual machine, or you can copy a disk image of your physical host, and you can save a copy of everything after you've set it up, after you've enabled Windows product activation, for example. The cost of computer equipment is another issue. The cost can be reduced by purchasing used or refurbished computers, monitors, what have you. Also, to save money, you can use a KVM switch, a keyboard, video, and mouse switch. So you can have multiple computers use the same keyboard, monitor, and mouse, which saves on space and does save on a little bit of money. I really encourage people to buy used or refurbished computer equipment if you're going to build a physical lab. It's just more cost effective and it is better for the environment as well. If you're running a virtual lab, you still have to consider the physical host that's running your virtual machines. It needs to have plenty of CPU cores, RAM, and disk space. So, for example, if you're doing a laptop and you want to run more than one virtual host, you're going to need a lot of resources. That means a bit more expense to purchase a laptop that has enough RAM, that has enough CPU cores, that has enough disk space. So should you use Windows 7 or Windows 10? Now, a lot of people use Windows 7 because, number one, I think it's cheaper. And well, I mean, there are many advantages to either one. Now, I prefer Windows 10 to Windows 7, especially now that Windows 7 is end of life and no longer officially supported by Microsoft, I guess, unless you have some sort of extended license agreement or maintenance agreement. But even then, that will end at some point, and most users don't have that. And malware authors are starting to take this into account. And I'm starting to see some malware samples that don't run under Windows 7, or they don't act like they should in Windows 7 compared to Windows 10. Windows 7 does have some advantages. For example, it needs less resources than Windows 10. It needs less RAM, disk space, what have you. That's an argument in its favor. And there is definitely less system traffic than Windows 10. I've heard Windows 10 referred to as spyware, for example, because of so much of the traffic that gets sent over the network from a Windows 10 host. Now, most malware does work on Windows 7, so Windows 7 is not a bad choice. It just may not be the best choice depending on which malware that you are trying to check. I generally do not test malware in Windows 7 unless the situation requires it. The biggest drawback to Windows 10 from my perspective is that all of the web traffic this operating system generates. It generates a lot of traffic. And that makes it more work to find the infection traffic when you're testing malware, because you have to sift through or filter through a lot of traffic to find the malicious activity. The image that we see here is just regular Windows 10 system traffic. Windows 10 does constant updates and update checks. A lot of telemetry that it's sending back and forth to various Microsoft domains. It is just, I believe the phrase is lousy with system traffic, just noisy. Windows 10 is very noisy. And in some cases, people have derisively referred to Windows 10 as Microsoft spyware. I wouldn't go as far as to say that. In today's modern computing environments and operating systems, you see a lot of traffic, whether it's Windows 10 or whether it's any major operating system. You generally do get at least a little bit of system traffic going back and forth. Windows 10 just generally tends to have a little bit more than other types of operating systems. But I say, why not both? I keep my Windows 10 lab host up to date. I disable or bypass security features on a case-by-case basis. And my Windows 7 lab hosts have out-of-date applications. And the Windows 7 lab hosts that I have are far more vulnerable than my Windows 10 lab hosts. For example, on a near daily basis, I can still find new malware samples that are Microsoft Office documents that use exploits based on a 2017 vulnerability in Microsoft Office, CVE 2017-11882. I test these on my Windows 7 lab hosts because they don't work on a Windows 10 host with more recent versions of Microsoft Office, because they tend to not let this particular vulnerability, exploits that use this particular vulnerability work. When we're talking about costs, if you want to simulate a Active Directory environment, a business or an enterprise environment with a domain controller in an Active Directory environment, you have to get a Windows Server license. And that alone can cost hundreds of US dollars. So I use both Windows Server 2008 R2 and I use Windows Server 2019. But that's a significant cost. That will add a significant cost to your lab environment if you want to test malware that is running in an Active Directory environment with a domain controller. Now, regardless of your physical or your virtual lab, your Windows hosts should look lived in, meaning they should have documents in the documents folder, pictures in the pictures folder, have some downloaded files and possibly some music or videos that are sitting in those appropriate folders, have applications installed, set up user accounts for online mail services, and anything where you can have an account that you're accessing from your lab host. Just be sure to change any passwords after you've set up your lab host and you've taken an image of it, or you've taken a snapshot if it's a virtual host. Now, the idea for your lab host is to make it look like a real host. And in order to do that, it should look like it's being used. It should look lived in. Up next, let's talk about virtual environments. What are the benefits? Well, there are quite a few benefits to virtual environments. A good reason to use virtual environments is that you can set it up on a laptop and it can be portable. You can take it with you if you're traveling, for example. If you're going to a conference, a security conference, and you want to check malware samples during that time, you can take it with you. And it also takes up far less space than a physical environment. And you can easily snapshot images. You can take snapshots of your Windows environment after you set up your Windows host. There are a couple of significant drawbacks if you are using a virtual environment. Mainly that some types of malware check to see if they're running in a virtual environment, and they either A, don't run at all, or B, they act differently than they would in a physical environment. Currently, malware that I see that doesn't run in a virtual environment, at least stuff like VMware or VirtualBox, is QAKBOT, QAKBOT. That family of malware does not tend to run in a default setup for VMware or VirtualBox. It's easy for malware to check if it's running in a virtual environment, and usually that's merely a matter of doing something like a BIOS check or UEFI check and seeing if it reveals a virtual environment like VirtualBox or VMware. Also, you're limited by the configuration of your physical host that you're running the virtual environment on. These are resource limits. For example, you cannot easily run a Windows 10 host in a virtual environment if your physical laptop that you're running it on only has 2 gigabytes of RAM and 120 gigabyte hard drive, and within that, you're trying to run a Windows 10 VM. It just is very hard, virtually impossible in that case. Well, let's take a quick moment here to talk about the different types of virtual environments that you could use to run a virtual host in a virtual lab. I've tried 3 options for virtual environments. The first one is VirtualBox, created or currently under Oracle, and it's free, but it's kind of a hassle to set up. And the next is VMware, which actually costs money to use features. There is a free version, but to fully be able to use the features like taking snapshots of your virtual hosts, you have to pay for that version. And finally, I've used a free virtualization software available through Linux. A couple of years back, I was using Ubuntu. It's a system called KVM, which is a kernel virtual mode, and QEMU, or QEMU. That's a virtualization environment. I've successfully used that on Ubuntu as my physical host, running those virtual environments. Once again, kind of like VirtualBox, it's a little bit of a pain to set up, but it actually works rather well. KVM, QEMU works rather well if you are just testing with a single Windows virtual host. But by far the most convenient and feature-filled virtualization environment is the commercially paid-for version of VMware Fusion for Mac OS or VMware Workstation Pro for Windows or Linux. As I mentioned, a good reason to run virtual environments is that you can set it up on the laptop. It can be portable. However, once again, your laptop needs to have plenty of RAM and at least a quad-core CPU with an SSD. Windows 10 tends to need a lot of resources. So if you're running a Windows 10 VM, you need this. 16 gigabytes of RAM in your physical host running that virtual environment, a quad-core CPU, and at least a 500 gigabyte SSD. So whether it's a laptop or desktop, these are the minimal specs I would recommend. You might be able to get by with less, but I would not recommend it if you're trying to do things right, in my opinion. Now, this image represents how a virtual environment would function. Your Windows VM or VMs, if you're running multiple VMs, would run within a virtual LAN that's being hosted in that virtualization environment. Also, note the VPN in this example, and I'll get to that a little bit later. But for VMware, for example, VMware virtualization software, the VLAN that we're talking about, there's they normally have designators of names, and the default name for the VLAN that hosts the VMs is VMnet 8. So for example, if I'm going to use Wireshark on my physical host to record traffic in those virtual environments, I would use Wireshark and record VMnet 8 in promiscuous mode to capture all the traffic. But we'll get into that, capturing network traffic from your lab environment, a little bit later. What I'd like to talk about now, what I'd like to emphasize, is using a VPN. You're using a VPN to hide your IP address, your actual IP address. For example, if you're in your home and you're running a virtual environment and you're on your home wireless, the infection traffic is going out, and the source IP is that IP that your home is using for Wi-Fi. So I've actually had this happen to me before. Early on, when I was starting to test malware in my lab environment, I did not start out with a VPN, so I was using my home IP address. And one day, I didn't have internet access. Turns out that my hosting provider, my internet service provider, I should say, cut off my internet because I had infection traffic going out of the IP address that I was using, my public IP address that I was using for my internet. So I had to call them. I had to let them know, hey, I'm researching malware. I don't really have an infected host. This was in a virtual environment, and they re-enabled my internet. But you really want to hide your actual IP address. Another issue is location-specific URLs. Sometimes malware will not work properly if you're coming, for example, from an IP address in the United States. and the malware is looking for an infected host that's coming from, let's say, an IP address in Germany. It's targeting specifically German hosts, so it may restrict its operations only to those IP addresses within Germany. Another issue that I've run across is as I'm infecting a virtual host and I reimage the machine to try it again, and I try infecting it, but I'm getting a different response from the command control server on the traffic. And I have to switch my IP address before I can get the same traffic that I saw before. So sometimes malware or the command control infrastructure that the malware uses will be wise. They will understand if you're coming from the same IP address over and over again. So you have to change your source IP before you can successfully infect your VPN. And if you don't have a VPN, I would suggest that you tether through a mobile device if you can. Now, tethering through a mobile device, usually you only have a certain amount of bandwidth you can use per month for tethering. If you can tether, also the connection tends to be slower. But on the good side is normally when I tether to my mobile device and I set up, for example, Wi-Fi sharing to my cellular network through my mobile phone or a tablet, I generally get a different IP address each time I tether, each time I set that up. So these IP addresses are usually within a specific block of IP addresses used by the carrier of your mobile device. Well, let's talk about virtual environments. Now, each of your Windows hosts should have at least 4 gigabytes of RAM, a dual-core CPU, and 80 gigabytes of disk space. Windows 10 really needs the RAM and the disk space. It's relatively easy to set up a Windows VM in your virtual environment. For example, here's a Windows 10 VM in VirtualBox. You just need ISO images of these Windows installation media, and it's all very easy to set up. Next up, let's talk about a physical environment. Sometimes it's just better to run malware in a physical environment because they don't run well in a virtual environment. And a physical environment is not limited because you can keep adding to it. The drawbacks is it takes up more space. Depending on how many hosts you want in your physical lab, it will definitely take up more space if you have a lot of hosts. You can't carry it around with you everywhere. It can be harder and more time-consuming to make and restore disk images of your physical hosts compared to a virtual lab. And let's look at my next host to show what I mean. Now, to reimage a physical Win10 host, you must hold the Shift key and keep it pressed down when you're shutting down. When you do that, when you reboot, you can access the boot menu. Otherwise, Windows 10 will not let you access the boot menu when you're booting. And I boot to a live environment on a USB stick Linux environment, and I use the DD command to copy an image of the C drive. Here's one of my physical hosts where I use a bootable USB thumb drive with Linux to reimage the host. I use SSDs, and the backup SSD is an image of the system drive. Now on the floor, outside of the case, you'll see an SSD that has the power cable hooked up, but not the data cable. This is a backup SSD. To reimage the C drive, first I shut down the Windows 10 host while holding down the Shift key. After the computer shuts down, I connect the data cable to the backup SSD, and then I boot the computer and enter the boot menu for the BIOS or UEFI so I can boot from the USB drive. Now, Knoppix is normally the live Linux USB boot environment that I use. And once I boot up and Knoppix is running, I open a terminal window. And before doing the command you see here, I usually use the fdisk command to list devices to make sure I'm copying to and from the correct device. And that is the command there that I use. The device dev/dev/SDB is the backup SSD that was sitting on the floor. The device that I'm copying to is /dev/SDA, which is the C drive of the Windows host. For laptops, I use a portable drive, and the command is a little different because I often store more than one disk image on a portable drive. For example, if the portable drive itself is 512 gigabytes, I can store at least 3 different images from physical systems that have 120 gigabyte system drives. And if you see here, the file that I'm copying from, the one that says IF is /media/SDC1/ whatever I name my image that I save. Now, this is a very simplified version of my physical lab environment. In my own lab, I have several hosts that I've collected over the years, and I can easily max out all of the ports on my switch. I'm only showing a Windows client and a Windows domain controller. Now, there's a computer that I have with 2 network interface cards that, and I can set that up to use a VPN connection that goes to the router over the internet, to the internet. And I can share that VPN connection with the network interface card that's connected to the switch. So my lab can actually, my entire physical lab can actually communicate to the internet through that VPN. Also, since I have 2 network interface cards on that computer, it helps isolate my lab from other hosts within my home network, other hosts that are connected to that router. You can add a wireless access point to your switch, not a wireless router, but a wireless access point. So I can have portable devices like cell phones and tablets on this physical LAN. Let's talk about recording the network traffic, because network traffic is a topic that's near and dear to my heart. In a physical lab, you can run DUMP, CAP, dump pcap, or TCP dump, or use Wireshark to capture network traffic. In this case, it's on the computer with 2 NICs, where 2 network interface cards, where you can record traffic in promiscuous mode on the NIC that's connected to the switch. Promiscuous mode should catch all the network traffic within the LAN provided by the network switch. Now, some switches do port spanning, so I can feed copies of all the packets from several ports on that switch into another port on that switch, like I show here with that red computer on the bottom, and then I could use TCP dump or dump pcap or Wireshark to record all those packets that are being spanned into that separate port and get another picture of the network traffic. In a virtual environment, you're doing basically the same thing, but instead of a physical LAN, you're recording the traffic on the virtual LAN in promiscuous mode. So up next, where can you get malware samples? You have a lab, you want to test malware. How do you do it? Or where do you get the samples from? Now, these following domains are all free services for retrieving malware samples. I frequently use the second one, URLhas, just browsing to see what URLs people have submitted and then downloading malware from those URLs in my lab environment. The third one, any.run, requires that you register for an account, which is free, but they have to vet you and know you're not a criminal that's trying to exploit their service. The last one, hybrid-analysis.com, was easy to register for a free account. All that one required was a valid email address, but really any of these sources could get you recent malware samples. And when doing malware analysis in a lab environment, dynamic analysis like I do, it's very important to have fresh, new malware samples. Because if you're analyzing a malware sample that first appeared, say, a month or 2 ago, the command control server that it communicates with may have already been taken offline. Sometimes this can happen as early as 10, 12 hours after a malware sample is public. Hosting providers get takedown notices, and they'll take these servers down. Some are not quite as timely as others, as far as hosting providers and taking down malicious servers. Many malicious Word documents or Excel spreadsheets retrieve malware binaries to infect a victim host, and they won't work if the server that hosts the malware binary has been taken offline. Now, another way I have of getting malware samples or finding out news about current malware samples is Twitter. I follow several security professionals on Twitter who routinely tweet about malware they've run across, and you can use hashtags on specific malware families to get samples that say something like Emotet or TrickBot or CACBot. You'll often have to sift through more general tweets from vendors and other people, but you'll start finding up-to-date malware samples that way. Here's an example of another fairly active malware family called GOSI or URSNF or ISFP by someone whose Twitter handle is @JamesWT_MHT. But I'll search for a particular hashtag on a malware family. I'll start by latest, and I'll start sifting through and looking for various malware samples. Now, my Twitter handle is @malware_traffic. And you can follow me to see what I've been up to. I don't retweet as much as some of these other people do, but if you can take a look at who I'm following on Twitter and start looking at their tweets, you should be able to set up a Twitter account if you haven't already and focus that Twitter account on looking for malware samples and malware indicators. And that really concludes the cyber talk. Now, I didn't get a chance to go into more detail because of time constraints, but also I don't want to reveal the details of my personal lab environments that I use in my day-to-day work. I just really cannot do that as much as I would like to. I'd like to thank you all for attending this cyber talk. Once again, I'm Brad Duncan, a threat intelligence analyst for Palo Alto Networks, Unit 42 Threat Intelligence Team. And now we should have some time for a question and answer session.